Hello everyone, this is Drishya G. Chandran, Assistant Professor, Department of Chemical Engineering at Hindustan College of Engineering and Technology. So, in this video, today we are going to discuss about the basic concepts of control system. Before moving to this topic, we want to know what is process control and for what purpose we use this process control in industry. So the process control is nothing but it is the ability to monitor and adjust a process to give a desired output, and it is used in industry to maintain quality and improve performance. Why process control? In almost all the industries there is a process, but that process we usually not fully known. Certain uncertainty is there. So the presence of this uncertainty and disturbances which will leads to the implementation of control system in process industries. One of the main classification of control systems are open loop control systems and closed loop control system. The first one is open loop control system. This open loop control system is nothing but the output or the response of the process is independent of the controller action. This traffic signal, electric hand dryer, automatic washing machine, bread toaster, automatic tea or coffee maker, light switch. These are the examples of the open loop control system. This is the block diagram of open loop control system. So, in this block diagram, we can see that the process output or the response that doesn't depends on controller action. That means the output from the process is not measured or not fed back to the input for comparison. These are the advantages of open loop control system. Its design and constructions are very simple, and it is an economical one, and it is easy to maintain, and generally it is a stable one. These are some of the disadvantages of open loop control system. First one is they are inaccurate, and second one is they are unreliable, and third one is any change in output cannot be corrected automatically by using this open loop control system. So, in order to overcome these disadvantages, we can use closed loop control system. And also we can convert this open loop control system into closed loop control system by providing a feedback. We already discussed the main classification of control system. So the second one is closed loop control system. This closed loop control system is nothing but the output or the response of the process that depends on the controller action. Because in closed loop control system we provide a feedback. That's why this closed loop control system it is also known as feedback control system. These are the four basic elements of control system. First one is process. Second one is measuring element. Third one is controller. And fourth one is final control element. This is the schematic representation of closed loop control system. It includes process, measuring element, controller and final control element. Now we can see it's working. First of all, we have to set one value, that is called set point value or the desired value. Usually a process will be having input and corresponding output. Once the disturbance or the load which is introduced into the system or the process, we do not get our desired output. That means the output or the response which is obtained from the process is deviate from our desired value. So at that time, the output value is measured by using measuring element. Mostly we use the measuring element as sensor. Suppose we want to control the temperature of a particular quantity of liquid. In that case, we use the measuring element as thermocouple. The measured value or the output from the measuring element is fed back to the comparator. Comparator is nothing but it's a part of controller. What is the function of this comparator? It is nothing but name itself comparison. Comparator which will compare two values. What are they? First one is set point value and second one is measured value. So the difference in set point value and the measured value is called error. So this error is given to the controller. At that time, based on this error, the controller will take one decision. And that decision is implemented by using final control element. Then the output from the final control element is given to the process. And this is the working of closed loop control system. And in industry, they use different types of controllers for controller action, that is P controller, PI controller, PD controller and PID controller. Sometimes they use some combinations of these controllers. P means proportional controller, PI means proportional integral controller and PD means proportional derivative controller and PID means proportional integral derivative controller. And industry, they mostly use the final control element as valve. These are some of the examples of closed loop control system. First one is liquid level tank, second one is servo voltage stabilizer, third one air conditioner, fourth one automatic electric iron and fifth one is cooling system in car. Now we can see some of the advantages and disadvantages of closed loop control system. Advantages, which include it is highly accurate as any error arising is corrected due to the presence of a feedback signal. Second one is the bandwidth range is large. And third one is it facilitates automation. And fourth one is this system is less affected by noise. These are the disadvantages of closed loop control system. First one is they are costlier. Second one is they are complicated to design. Third one is it required more maintenance. Fourth one is feedback leads to an oscillatory response. Fifth one is overall gain is reduced due to the presence of feedback. And final one is stability is one of the major problems. So more care is needed to design a stable closed loop system. So in order to overcome these disadvantages of this closed loop control system, we can use advanced control system in process industries. Thank you.